The empirical rule is basically a rule that is for bell-shaped distributions. For example, when I made you draw a histogram in previous sections, you had something that looked like this, right? But what I didn't tell you is actually there's a curve that goes something like this, right? That's called a bell-shaped curve. We're going to discuss that a little bit more in the next section, okay? So it kind of looks like a bell shape, okay? Now, one of the things about the empirical rule is that it states when data, like for example in this histogram, when data is actually bell shaped, when data has a bell shaped distribution, it is symmetric. So that would mean that the mean is the same as the mode, is the same as the median. Also, the empirical rule says number one, about 68% of data fall within x bar plus or minus s. 2, about 98%, about 95% of data fall within x bar plus or minus 2s. So s is the deviation, x bar is the mean, right? So here we have one deviation away from the mean, and here we have two deviations away from the mean. There's one more that we rarely use in the class, but I'm going to mention it. About 99.7% of data fall within x bar plus minus 3s. So for example, suppose we have our first exam soon, which we will, okay? Suppose the results of exam 1 have a bell-shaped distribution with x bar equals 84 and I'll say the deviation is s equals 6. So the average was 84% and plus or minus 6 points, right? Now by the empirical rule, would say that about 68% of scores fall within right? So x bar plus or minus s. So here we go. X bar plus or minus s. So let's go ahead and plug in. I'm going to go ahead and highlight x bar in yellow. And I'm going to highlight in green. I'm going to highlight the s equals 6. Plug it in here. So here we have 84 plus or minus 6. So what you're going to do is basically add 6 to 84. So you're basically doing two computations. 84 plus 6, which is 90. And you're doing 84 minus 6, which is 78. So the answer is 78 to 90. About 78 to 90, about 68% of the students got a 78 to a 90. Okay. And then what about the second one? Let's just say about 95% of the students, 95% of scores fall within x bar plus or minus 2s. Okay, so that's what it says up here, right? 95%. So then that means that I keep plugging in the same way. Okay, 84 is the x bar. Now the formula now has a 2 in there. The s is going to be the same as 6. 84 plus minus 2 times 6 is 12. So now add 12 and then subtract 12. You're going to get 72 to 96. See how it opens up a little more? 95% of students got 72 to a 96. A lot of things are bell-shaped distribution. Lots of them. The next example, for example, nurses' salaries. Okay. Nurses' salaries have a bell-shaped distribution with the mean salary probably a little higher now than this example. This is actually a pretty old example. $6,400 and S equals 300. So by empirical rule, if I'm asked to find if I'm asked to find 68% of nurses, what is the 68% range? So about 68% of nurses make within x bar plus or minus s. Right? S is 300. X bar 6,400. And that's 6,400 plus or minus 300. So that's 6,100 to 6,700. Two. About 95% of nurses make within, so at 95% level, you're actually talking about x bar plus or minus 2 deviations now. Right? You got 2 deviations. So here we have 6,400 plus or minus twice 300, which is 600, right? 6,400 plus or minus 600. Subtract 600 to the 64, you get 5,800. To add 600, you get 7,000. Oops. And that is how we use the empirical rule.